Alright guys, in this video I thought I'd do something a little bit different, and I thought I'd do a small presentation on narrowband oxygen sensors. Now it's not going to be very long, so I hope you guys enjoy it, and let me know down in the comments if you guys would like to see other videos like this. So let's get started. So in this presentation I want to go quickly what is an oxygen sensor. I want to go over the components or its construction of the oxygen sensor, and I also want to go over its operation, and I will do a separate video on diagnosing a oxygen sensor. So what is a narrowband oxygen sensor? An oxygen sensor is a device that is placed in the exhaust system. On modern vehicles, they are placed pre-catalytic converter and post-catalytic converter and measure the amount of oxygen that remains in the exhaust gas after combustion. Now, there are two styles presently used on vehicles today, the narrowband and the wideband. I will only be going over the narrowband in this presentation. And I put a picture of a narrowband oxygen sensor there for you guys to view. Now, the narrowband oxygen sensor. It was invented in the 1960s by Robert Bosch. Why? Due to the strict emission regulations that were coming from the governments, auto manufacturers were looking for a way to lower emissions, thus the oxygen sensor was born, along with vacuum-controlled PCVs. Many countries in Europe were the first to adopt this technology, then the Americas followed later on. A narrowband oxygen sensor got its name for its very narrow range of operation from stoichiometric 14.7 to 1. Example, 14 to 1 to 15 to 1. And Volvo and Saab were the first auto manufacturers to use the oxygen sensor in the late 70s. Now we're going to go through the main components of an oxygen sensor. So, into a narrowband oxygen sensor, also referred to as a zirconia oxygen sensor, we have a zirconia ceramic element. Now, what does this do? This is the heart of the oxygen sensor. It's what allows the oxygen sensor to actually read the oxygen content. After that, we have a heating element. Now, the heating element is used to help to aid in the heating of the zirconia ceramic element. Then we have two platinum electrodes. One is placed in the exhaust stream, and one is placed outside of the exhaust stream to read the atmospheric oxygen content as a reference point. And then we have a metal case that is connected to a ground supply for the sensor. Now, the O2 sensor operation. Now, how does the O2 sensor operate? The first step in O2 sensor operation is getting the zirconia ceramic element to 600 degrees Fahrenheit or 316 degrees Celsius. Until the O2 sensor reaches this temperature, your fuel system remains in open loop or a predetermined fuel map that is loaded inside of the ECM, and the O2 sensor is not active. Earlier systems used 1-wire and 2-wire unheated O2 sensors, which use the exhaust gas to heat the O2 sensor to operating temperature, but due to the increasing emission regulations, 1 and 2-wire sensors were soon phased out, leading the way for a 3-wire and today's standard, the 4-wire. Now you have to be careful when you have a 4-wire oxygen sensor, because there are some manufacturers out there that actually use a 4-wire wideband oxygen sensor. So just keep that in mind. Now, on today's modern vehicles, we use a heater element placed in the center of the zirconia ceramic element. Just for viewing ease, I put it on the exterior, but this heater element actually runs through the center of the sensor itself. The heater element has a system voltage supply and a ground supply. Now, the power supply will most of the time be relay controlled and fused. The ground of the heater element will always be computer controlled or PWM on modern vehicles. So after the sensor reaches its operating temperature, what happens? The sensor becomes active and the fuel system enters closed loop and starts to read the difference in oxygen between the reference O2 content of the atmosphere and the O2 content that remains into the exhaust. Now, how does it do this? There are two porous electrodes placed at either side of the zirconia ceramic element. One is reading atmospheric O2 content, while the other is reading exhaust oxygen content. Now, in order for this sensor to work properly, atmospheric oxygen is brought into the sensor and kept in what is called a sampling chamber or a reference chamber. Now, this is where the magic happens. So once the sensor is at operating temperature and all is working properly, the difference in O2 content between the sampling chamber and the content that remains in the exhaust after combustion makes the zirconia ceramic element create a voltage. The voltage that is generated is proportional to the amount of oxygen content that remains in the exhaust gas. Now, the voltage that will be as low as 0.1 volt, which is lean, and as high as 0.9 volts, which is rich. So now that we know how a sensor operates, I wanted to take a quick minute to go over what it looks like onto a scan tool. The first line that you're going to see is going to be voltage. Now, your voltage is going to be from 0.1 volt up to 0.9 volts. The second line that you're going to see is going to be your voltage over time. Third, we are going to end up seeing a stoichiometric line or a 450 millivolt line. Now, it's important to remember that anything above 450 millivolts is rich and anything below 450 millivolts is lean. And lastly, when everything is working properly, we have a waveform that is produced. Now, on a good working sensor on modern vehicles, the signal will switch between 5 to 7 times per second at roughly 2500 RPMs. So that basically covers what is a zirconia ceramic oxygen sensor and how it operates. And in my next video, I will be showing how to diagnose it. So I hope you guys enjoyed this little video, and I will see you guys next time.